In section 7.4, we'll talk about factorials. So, first off, we take factorials of natural numbers. Natural numbers are positive integers, 1, 2, 3, etc. Okay, and I'll even show you what it is for 0 as well, because we may need that. But the factorial, the representation of a factorial, the notation, is the number followed by an exclamation mark. Okay. And what this means to do is to take and start with that integer and multiply that by the integer that is 1 less than that. So if you start with n, the integer that is 1 less than that is n minus 1. Then you're going to take that integer and multiply it by 1 more less than that. All right, so one less than that. So we had n minus 1, so now we have n minus 2, and then it would be n minus 3, and you keep going until you get down to 1. So times 2 times 1 there at the end. So you multiply all of the integers from n down until you get to 1. And that is called the factorial of the number. Well, we've already seen where we use this, at least in part, right? We had, on the previous example, we had 5, 4, 3. If it had been a little bit of a different problem, we would have gotten down to 2 and 1. But this is the idea. This descending numbers come up so often, they created a notation for it. It's fantastic. All right. Oops. Let's do this one next. If we had 1 factorial, that is simply just 1 by itself, because it's sort of the end of the road. And this one, we'll go ahead and do the 0 for this one as well. 0 factorial is defined to be 1. Now that looks a little strange. How does 0 factorial become 1? There's actually a deeper meaning to factorial. Really, the factorial is the number of ways that you can rearrange things in order. Okay, so if I had, 4 things and I wanted to rearrange them, take for example these 4 pins, right? How many ways could I rearrange these 4 pins on the table? Right? Well, it would be 4 times 3 times 2 times 1, but that's 4 factorial. So that's really what the factorial means. Now for this would be 0 factorial. So the question is, how many ways can you rearrange 0 things? And the answer is 1 way. Nothingness. There it is. Boom. It's just 1 way. Yeah, Frank.
Getting back to the top one.
Yeah.
Just trying to find out. Just trying to visualize how you went from negative n minus 1 all the way down to 2 and then 1. It's almost like a countdown, go backwards, forward. So
Yeah, you're going to count it down from whatever number is here. So let's do the example. How about that?
Please.
So example 1, 4 factorial. So you would start with 4 times 3 times 2 times 1. And that's 24. Okay, go ahead and do the other 3 with your partner. And just so we're all on the same page, the one on example 4 on the bottom, those 2 factorials need to get multiplied after you do the factorial. Okay. All right, so go ahead and do those real quick. No, it only goes down to 1. So you just didn't have enough here. Yeah. Really what you can do is do this instead.
Oh, cool. Thank you.
No, this 5 cancels with that 5.
Oh, yeah, so it's just 6 over. Yeah, well, 6.
What do we got? Yeah. Cancel as much as you can there.
Yep.
See if you can do some canceling. That's really the game here. Can you do some canceling? Yeah. Try to write that out so that you can see what cancels.
So do 6 to the
Just so you can see what's going on. You're gonna see a pattern. All right, let's start. All right. In example 2, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And what is that? 40,320? Yes. All right. In example 3, 6 factorial over 5 factorial. If you write this out, you'll see a pattern here. So 6 factorial is 6, 5, 4, 3, 2, 1. And then 5 factorial is 5, 4, 3, 2, 1. And so what happens? These all cancel and leave us with 6. And same thing here on example 4. So we have 9 times 8, 7, 6, 5, 4, 3, 2, 1. Over 2 times 1 times 7 times 6 times 5 times 4 times 3 times 2 times 1. These cancel with these. And let's do this one here. The 2 and the 8 cancel and give me a 4. So this is really 9 times 4, which is 36. Bingo. Let's go ahead and add one more rule to the top here. So that you can remember this. Oops. N factorial is also equal to n times. Now, what would be left after the n? N minus 1 times n minus 2 times n minus 3 all the way down to 1, right? Which is n minus 1's factorial itself. So the factorial symbol here is only affecting the n minus 1. And so that means you would start with n minus 1, which is here, and you would get all the rest of these down here. And times that. I call this peeling the onion. Right? You've taken one layer off the n factorial, which is the n, and now you have another factorial. It's an onion, right? Okay. All right, so questions over factorials. All right. If you have your TI calculator, you can use that on some of these next ones here. So we'll talk about permutations. And I talked a little bit about permutations when I described the pins and things. This was a sort of a more generic version of permutation. Basically, a permutation of a set of distinct objects is an arrangement of the objects in a specific order without repetition. The key word here is specific order. And that's going to be our big thing about a permutation, is that the things come in a particular order. Right? If the items are in a different order, that's a different permutation. Okay? The notations for permutation are little n, big P, and then a little r with the n on the left. Or some people do it this way, P with little n sub r. Or, this is the one I use a lot, P parentheses n comma r. Now the phrasing that I will use in this class with permutation is n pick r. And use pick for the P for the permutation. I'm the only one that does this. So if you go to a tutor or Slack or whatever and say, well, it's n pick r, they won't know what you're talking about. You'll have to explain it to them. Okay? But this is to help you sort of distinguish between permutations and then what's coming up next. Now these functions are in your calculator, and you can access them through the math button. So if you have your calculator, some of you already found these, right? You can go to math, and then you want to get to probability, PRB rather, and that's the one on the end here. You can get to that one by going from left to the right immediately by doing left, and it comes up there. And then you have the three ones that we'll use here, NPR, NCR, and the factorial. You just have to remember, if you're doing the permutation or combination, you have to enter the first number first, and it's really this first notation that they use. Here's the example. This is 7, pick 3, is 210. Now, the formula for a permutation is the following. I'll just do it this way. Permutation in pick r is n factorial divided by n minus r factorial. That is the technical formula for permutation. The practical way to do a permutation is to sort of do the factorial of the n, but only go out r numbers. Okay? And I will show you that in this example here. Bob has 6 books. How many different ways can 3 of the books be set on his shelf in order? All right? So the first question you're going to ask when you do problems like this is, does the order matter? The answer is yes, it even says so. Some of these you're going to have to figure out if the order matters based on context. Okay? But the order matters. That means we're doing a permutation. And then the questions are this. How many objects do you have to pick from? There are 6 books to pick from. And then how many objects, how many books are you picking? You're picking 3. So I'm going to do this problem twice. I'm going to do it with the technical formula for permutation. This would be 6 factorial over 6 minus 3 factorial. So that would be 6 factorial over 3 factorial, which is 6, 5, 4, 3, 2, 1 over 3, 2, 1. So the 3's cancel, the 2's cancel, the 1's cancel. And now I'm going to write this out so that you can see what I was talking about earlier. When you work this out, it boils down to 6, 5, 4. So the shortcut way of doing the permutation is to start with the number of objects you're choosing or you're picking from, and then just go down R numbers. So 1, 2, 3. And you sort of truncate the factorial at that point.
For 6 minus 3, did you just get that with 6 books minus 3 different ways?
Right.
Okay. You got
This 3 is this 3 here.
Okay.
Yeah.
So you wouldn't just start off with the information with 6 over 3. You'd have to do 6 minus 5.
Yeah. And what number is that? 120? Yeah. What if this had been a 2 instead? Then this is 6 pick 2, and then 6 factorial. Let's go ahead and write that one. Let's just do it. What if we wanted, what do we say, 2 books? Yeah, 2 books instead. Let's do 2 books. So that would be P 6 pick 2. So it would be 6 factorial over 6 minus 2 factorial, which is 6 factorial over 4 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, over 4 times 3 times 2 times 1. And then you would cancel off 4, 3, 2, and 1. But notice, how many numbers does that leave us with? It leaves us with the 2 numbers, 6 and 5. That's what the minus part does. It tells me how many numbers we're going to have left over after the cancellations. So this would be 30. 6 times 5 is 30. Okay. That's 120 and that was 30. And you could do this in your calculator as well. If you have your calculator, go ahead and put in 6, NPR, 3. And then hit enter, and it should come up with 120. Okay. All right, I'll let you work on the group work. Let's see, how many group work questions do we have? 3 questions, 1 on the back. So go ahead and do that. I'll come around and help. Yeah, and be sure and write out the using the permutation. So, yeah, and you can use any one you want. PNR, NTR. Not only do we want the answer for these group works, we want the notation as well. So be sure to use permutation notation.
This be this.
No, n is the number that you're picking from, and 3 is the number that you would take off the R. But you don't put the n in the R when you write the notation. The n is the number, the R is the number, the p is the notation. Yeah. Does everyone understand that the p is the permutation symbol? The n and the R are numbers. So you don't write a number, then NPR, and then yeah, that's fine. That's why we need something like that.
So it's like, I want to go from that. My grade at. So you're saying you're doing that with solution. It's huge. Started it. This one still happened to be 3.
That's why we did the 1 for 2. If it's 6 minus 2, then that's 4. Where'd you get? Which house? No, it's less than Greek. It's like 21. Everybody knows how many letters there are in the alphabet, right? 6.
Yeah.
All right, let's check it. So how many ways can 5 people sit in 5 chairs in a row? So that would be permutation, 5 pick 5. There's 5 people, there's 5 in the chairs. So if you did the long formula, it would be 5 factorial over 5 minus 5 factorial, which is 5 factorial over 0 factorial. This is why we needed 0 factorial. This would be 120 divided by 1, which is 120. That's one way to do it. I think on some of these smaller ones, you're going to like this other method better, right? Where you just go, you have 5 things to pick from, and you want to pick all 5 of them. So it's going to be 5 times 4 times 3 times 2 times 1. And you get all the way down, and that's 120. Let me show you how that would work on this one. How many ways can 12 people sit in 5 chairs in a row? So that would be 12 pick 5. And so we're going to go down 5 numbers. We're going to go 12 times 11 times 10 times 9 times 8. And what is that? 95,040? Is that right? Now, if you did use the formula, it would work out, but it's longer. And I think you get more by doing this. Because think about what a permutation is. It's just the multiplication principle with a certain number, right? You have 12 things to choose from. You had 12 people to choose from. They sat down, one person sat down in a chair. How many people are left to be seated? 11. That person sits down. How many are left? 10. How many are left? 9. How many left? 8. So that's all it is. It's a multiplication principle, but a very fancy one where the next choice is just one less than the previous one. It's not like the ice cream and the peanuts and things where it's 3, 2, and 2. It would have to be 3, 2, and 1 if it were the permutation type. Problem 3. How many 3-letter passwords can be created using distinct letters? So distinct means that they are all different. How many letters are there? 26. How many letters are we using in our password? 3. How do we know that this is a permutation? So suppose your password was cat. C-A-T. Could you go to the computer and type in tack and get access? It has to be in order. Yeah. That's the key here. For a password, the letters have to come in order. That's what makes it a permutation. And they have to be in order. This would be 26 times 25 times 24. And what is that? That's 15,600. All right, questions over permutations?
Couldn't it be 3 and 26?
The first number is the number of things from the set you're choosing from, and the second number is the number that you're choosing from that set. If you tried to do the reverse on your calculator, it would not do it for you. If you did 3, pick 26, it says 0. Yeah. Because what you're asking there is, from 3 things, pick 26 of them. You can't do that. Yeah. All right. Next up is combinations. A combination of a set of indistinct objects taken R at a time without repetition is an R element subset of the set of N objects. The order of the elements in the subset does not matter. Okay, so that is the key. In a permutation, the order matters. In a combination, the order does not matter. So you're going to have to read the problems and distinguish the scenarios by which does the order matter or does the order not matter. This one is so popular, there are 4 notations for it. And they're all in choose R. Now, in choose R is universal. You can go up to anybody and ask them about in choose R. The pick one, I made up. This one, you can talk to them about. This is in choose R, in choose R, in choose R. And this one, it looks like a fraction, but it doesn't have a bar. It's just an N on top of an R in parentheses. The parentheses are part of the notation. Those are all notations for combination. The formula for a combination, it starts off like the permutation formula. But then you have to divide by something else. And as it turns out, what you are doing when you form a combination is you are taking the permutations and grouping them by the ones that have the same thing. So my previous example with your password of cat, right? Suppose we were just looking for a group of 3 letters. Well, cat, C-A-T, would be the same as act, A-C-T, and tac, T-A-C, if I took out the ordering. It's just, here are 3 letters, a C, an A, and a T. If we take out the ordering, then it becomes a combination instead of a permutation. There are more permutations than combinations in general, right? There's never more combinations than permutations, but they could be an equal number. And so what we have to do now when we form combinations is strip off the ordering. So for example, if we did have C-A-T, cat, there are 6 ways to rearrange the letters C, A, and T, because there are 3 letters. 3 choices, 2 choices, and then 1 choice. And it turns out that it's this R that is the number of choices for the rearrangements. So you end up dividing by R factorial. All right. Now you can think of this as well. Permutation n pick R divided by R factorial. And in fact, this is what a lot of people do. This is what we will do. Example number 6. How many ways can a 3-member team be chosen from 5 people? So if we're talking about 5 people to choose from, and we want to form a 3-member team, notice that we are not implementing any sort of ordering at all. We're just saying, here's 5 people, and I just need to end up with 3 people. Here we go. So that would be a combination. So it's a combination of 5 choose 3. And I'm going to use this sort of second formula to show you how this works. Aside from using the calculator, the way to do this is to start with the 5 and run it down the number of numbers that are the number you're choosing. So you, So we're going to start with 5, then 4, then 3. I went down 3 numbers, just like in a permutation. Just like the permutation right there. Now I have to strip the ordering away. When I strip the ordering away, I divide by the factorial of the number I chose. So 3, 2, 1. What's 10? Okay. Let me show you an example on the chalkboard that I've used in the past. Suppose we start with the letters A, B, C, and D. And I want to form all 2-letter subsets. Okay? And first off, let's do it in order, with order. Right? So we could have AB and BA. So if we assume order matters, then those two things are different. Okay? AC, CA, AD, DA, BC, CB, BD, DB, CD, and DC. So I had 4 letters, and I wanted 2-letter subsets. If the order matters, then that number is 4 pick 2, which is 4 times 3, which is 12. Are there 12 there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be all 12 2-letter groupings where the order matters. Is that clear? I'm about to change the table. Okay? Now what if the order doesn't matter? The only thing that matters is which 2 letters you have. If that's the case, then what do we know about AB and BA? They're the same. So now I'm going to group these together. That's the same, 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 and that's the same. Now how many groupings of these 2 letters do I have? 6. There are only 6. This would be a combination. And it would be 4 choose 2. And so you start off like a permutation. 4 times 3. You start with 4 and you go down 2 numbers. And then you divide it by 2 factorial. That was 12 divided by 2, which is 6. Okay. What you're doing when you divide by 2 factorial is you're saying, how many ways could I possibly rearrange just these letters? Well, there are 2 letters, so I can rearrange them 2 factorial ways. 2 times 1. And that's how you go from a permutation to a combination. And that's the same thing that happened here. We had 5 choose 3, so we started with 5, and we went down to the 3rd number. So 5, 4, 3, and then we divided by 3 factorial. See, in this example here, suppose I choose Al, Bob, and Carl, right? That's one grouping, right? But that's the same grouping as Bob, Al, Carl, or Carl, Bob, Al, or any other order. They're all the same. So we just go with that one grouping, and we divide out the number of ways to actually rewrite each of those. Questions? Okay, go ahead and do the next 3 group work problems. choose 2, you only go down 2 numbers. You only go down this. You only go down that many numbers. Yeah, okay. If you're going to write it like this, they got to be small.
Oh, okay.
They got to be subscripts. Yeah. See, that's an actual. Basketball. Yeah. What you're choosing from?
You're just starting out with 3. Should it be 6? Yeah. Oh, because it could be reversed.
Right.
Leave behind the verge.
Okay, let's check.
I'm late.
Are we ready to check them? All right, number 1. A nursery has following types of trees: ash, birch, pine, oak, and maple. Lisa wants 2 different types of trees for her backyard. How many ways can she choose the 2 different trees? So the first thing you need to start thinking about is whether or not this is permutation or combination. Does the order matter or not? In this one, the order doesn't matter, right? Because all she cares about is having 2 trees in her backyard. Birch and a pine and a birch, that's the same thing, right? So this is a combination. How many trees does she have to choose from? 5. How many trees is she choosing? 2. So that's 5 times 4 divided by 2 times 1, which is 10. That's interesting. So 5 choose 3 is the same thing as 5 choose 2. Who can explain that? That is true. Oh, I'm thinking bigger, not bigger explanation. Think of it this way. When you choose 2 of the trees to come to your house and be in the backyard, you are explicitly not choosing 3 other trees to stay at the nursery. Isn't that neat? It's like, well, we'll get to other examples that are like that. But yeah, choosing and not choosing, that's the same thing. For choosing. It doesn't work with permutations. Permutations do not work that way, but choosing does. Number 2, a basketball team has 9 players. How many different ways can the 5-player starting roster be chosen? So does the order matter? This order doesn't matter. Now, you may hit a problem that says, how many ways can we have the quarterback and the running backs and the tight ends and the linebacker and all this sort of stuff? If that's the case, then the order matters, right? Because who's going to play quarterback is different from who plays receiver. That's a different team. All right? If Romo suddenly starts playing tight end, then we have a different Cowboys team, right? So the order matters if it is more specific. If it's very general, like how many players are on the roster, then it's not. So this is a combination. 9 choose 5. And what is 9 choose 5? Is that 126, right? Yeah, 126. Do that in the calculator. All right. This one from actual life experience. An ice cream parlor offers 31 different flavors. How many different bowls of 3 flavors can be formed? Does it matter if the vanilla is on top of the chocolate? No. That does not matter. So how many flavors do you have to choose from? 31. How many flavors are you choosing? 3. And what is that? How much? $44.95. Okay. All right. There you go. Okay. Cards. How many people have played cards before? Any kind of card games? Okay. You are responsible for knowing the structure of cards in order to do some of these problems on homeworks and quizzes and tests. So I thought we'd go over that a little bit. Cards, each card is made up of 2 things. There's the rank and the suit. Right? The rank is 2, 3, 4, etc., all the way up to a 10. And then Jack, Queen, King, and Ace. And then the suit. What are the suits of the cards? There are hearts, yeah, spades. I'll put that over here. Spades, clubs, and diamonds. Okay. So one thing you want to know about the suits of cards is the hearts and diamonds are what color? They're red. And the spades and the clubs are black. How many different suits are there? There are 4 suits. How many different ranks are there? 13 ranks. For a total of 52 cards. Okay. Not counting jokers, right? So what you'll see me write in questions and things is standard deck of 52 cards. No jokers, just the 13 ranks and the 4 suits. We also have face cards. Face cards are which of the ranks?
Jack, King, Ace.
Almost. The ace is not a face card. Just the 3 roll cards. Jack, Queen, King. Those are the face cards. Face cards. Oops. How many total face cards are in the deck? 12. There are 12 face cards. 3 for each of the 4 suits. Okay. So if we know this, then we can do things with it. Now, you sort of think of there being an order to the cards. You have to think a little bit more abstractly. There's not really an order to the cards. The games that you play with the cards impose a certain order. For example, is the ace a high card or a low card? Depends on the game you're playing, right? In poker, you can use the ace on a straight as a high card above the king, but you can also use it on the bottom side as a low card. Don't they call that when it's down at the bottom of the wheel straight? Is that right? It's been a while since I've played poker like that. So. But again, it's based on the cards. We used to play this game at home called Sariki, where we didn't use all of the cards. We took out some of the middle cards. We took out the 8, 9, and the 10. So the sequence of cards went ace, 2, 3, 4, 5, 6, 7, Jack, Queen, King. And the ace was not allowed to be at the top. It had to be at the bottom. So the order of the cards is dependent on the game you're playing. So just remember that. All right. We have group work already. Okay, so I'll let you do some of these group work activities. Now remember, when you're going to do these problems are all mixtures of combinations and permutations. Okay? And maybe some multiplication principle thrown in as well. Okay? What I want you to do is work with your partner, discuss these problems thoroughly, and decide, does the order matter before you do anything? Because the order, mattering or not, determines whether or not it's a permutation or a combination. And then, remember, anytime you're doing a permutation or combination, it's always the number of things you're choosing from, or picking from, and the number of things you are picking or choosing. Okay, I'll give you 2 minutes to work with your partner on that. If you don't have a partner, I want you to work together so we can talk about these. So learn more by working together. Do all 7. Yeah, do all 7. There are 7 groups of problems. Do all 7.